Welcome to your proportions unit test review. This is for retaking it. If we did not like it the first time, we're going to do better the second time. Let's do this. Number one, we're going to write ratios of girls to boys in our class, and it is 14 to 16. So there's three ways to write it. Let's write it as a ratio, which would be 14 over 16. You could write it 14 ... 16 or 14 to 16. Now, it does say write it in simplest form, so I might just go back and maybe simplify it by 2 and get 7/8. Maybe 7 ... 8 or 7 to 8. There you go. All right, let's take a look at number 2 now that we've warmed up. Find the unit rate. Unit rate always has a denominator of 1. We want to get it down to one single unit. First thing I'm going to do, and I insist that you do because it's the best, is let's label. All right. So I'm going to label it right here. We're trying to get avocados and their cost. Oh, I know I want to get it down to one avocado. So I want one single avocado. So that means I'm putting avocados down here in the denominator, which means money goes on top. And usually money actually does go up top in the numerator when we do these. Okay, now I'm going to fill in some of the info. Here we go. If 12 avocados right here, cost $49.99, how many would get down to 1? All right, so you can cross multiply or just divide. $49.99 by 12. Let's do it. And you should end up with $4.17 per avocado. Make sure to label it. It's per avocado. All right. Okay, the next one. Ooh, we know that this line means to divide. So let's just rewrite it. We're not going to be afraid of this. We got complex fractions. Do not change these into decimals. You need to leave them like we did in our fraction unit. So that is 8/11 divided by 4/5. And we're dividing. I know your teacher in elementary school taught you to keep change and flip. Let's do it. So 8/11, I'm going to change division to multiplication. And I am going to do the reciprocal of 4/5. There we go. Now you can multiply straight across and then simplify. I don't want to. I would really like to simplify first. 4 goes in here once, 4 goes in here twice. So I know my final answer is 10/11. That is simplified as far as it's going to get. All right, let's do this one. This is a big number, 4, divided by 3/8. So let's write it out. 4 divided by 3/8. All right. Let's write that as a fraction. We're going to change the division to multiplication. And I'm going to do the reciprocal, 8/3. Now, I'm going to look to cross cancel, and phooey, there is no cross canceling. Darn. I'm going to get 32/3. And it can't be simplified because I couldn't cross cancel. I'm done. You could change it to mixed, but you don't need to. All right, let's go on. Once again, going to make you label. A marathon runner can run 2/3 of a mile in 2.5 minutes. What's the runner's mile per minute? So minute, that's unit rate, goes in the bottom. Let's label it in the denominator. Minute goes down here. And that means I'm doing the mile up top. All right, here we go. So now I'm going to fill in some info. Marathon runner can run 2/3 of a mile. 2/3 of a mile in 2.5 minutes. Ooh, I could put 2.5. I'm not putting a mixed fraction in there. Let's change it to improper. Change this. 2 times 2 is 4 plus 1 more. That's 5. Keep the denominator the same. Look at that, 5/2. Now that's a problem, just like all the other ones we just did. All right. 2/3 divided by 5/2. We got this. 2/3 times, do the reciprocal, 2/5. Can I cross cancel? I cannot. And it's 4 over 15, but it's a word problem, so go back and add some words. It says a marathon runner can run, and I'm trying to figure out what is the mile per minute rate. So that would be miles per minute. I could also go 4 divided by 15 now that I'm done. If I really needed a decimal, I could write 0.2, I'm going to round 7 miles per minute. Okay? All right, the next one says determine if these tables are proportional or not. If they're proportional, we have to find the constant rate of proportionality. They should be the same or proportional. All right, so let's zoom in on this one. Here we go. This is my x, this is my y, and I know that k is always y over the x. So, for example, this would be 26 over 2. If I simplified that, isn't that just 13 over 1? Now try the next one. 13 over 3, 78 over 6, 130 over 10, 146 over 12. Do they all have the same constant of proportionality of 13? Or 13 over 1 if you want? All right, I'm not going to put it over 1. K is 13. If so, you're going to put yes. If they don't have the same one, you're going to put no. And if they don't have the same one, we can't even put it right there. Okay? All right. What'd you get? The answer is no because of this last one. 146 over 12 is like 12.2. It's not 13 over 1, so this is a big no. All right, let's do the next one. Here we go. This is my x. That's a highlighter. That is not helpful. All right. X over y. No, y over x. Let's do it. Y over x. I'm going to be careful what I say. So that'd be 2 over 8, which simplifies to 1/4. Does 3 over 12 simplify to 1/4? 4 over 16? 5 over 20? Go ahead and check those. And the answer is yes. They all simplify to 1/4. That is our constant of proportionality. All right. This one, let's take a look. You want to start? We could start with any of them. Look, 18 over 12. 6 goes into 18 3 times. 6 goes into 12 twice. So our constant of proportionality should be 3 over 2 if this is proportional. All right, let's do 15 over 9. 12 over 6. We should be looking for a pattern, right? 6 over 0. What is happening? This is 3 over 1. This one's 2 over 1. No. That is a big no. They are not proportional. All right. This one's going to go a little faster. Here we go. All right. Determine if they're proportional or not. Look, this has a constant rate of proportionality. It would go through the origin. So the answer is yes. My rate of change is 4. That's what a normal constant of proportionality looks like as an equation. Look at B. B looks good, except what's this on the end? That means that even if I started, if I started at 0 hours, let's see if we rented something for 0 hours, they would still charge me $2. That does not go through the origin. That's a big no. All right, this next one. This last one, oh my goodness. I don't even know what it is because why it's not isolated. I'm going to divide by 8. Y equals 1/2 x. Now, don't panic. I didn't put this on your test. All right. But look, this is constant. The constant of proportionality is 1/2. Nothing's added at the end. Remember, we aren't supposed to have anything on the end. So 1/2. This is a big yes. All right, backside. Dun, da, da, da. Determine if they're proportional. In order to be proportional, they have to be a straight line and through the origin. Look, this one's straight and goes through the origin. Remember, the origin is down at the bottom, right here. Boop, 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 boop. There it is. All right, so this is a big yes. How about this next one? Big yes. How about the one below? Big yes. They all are straight and through the origin. Now I'm going to go back and find the constant of proportionality. Don't forget, it's y over x. So let's look up here. To To go from here over, I went up 2 over 1. 2 over 1, isn't that just 2? And to write that as an equation, it'd be y equals 2x. Let's do the next one. I would go up to this point and over this point. All right, zoom in. If you don't like that point, you can use this point. Up 10 over 2 or up 5 over 1. Up 5 over 1, that's my y over the x. Isn't that just 5? Yeah, so the equation is y equals 5x. All right, we're doing great. Hang in there. All right, last one. On this graph here, we would go up 3 over 3 to get to this point, or this point, or this point, right? 3 over 3? The y over the x, isn't that 3 over 3, which is just 1. My equation is y equals 1x. Do I even need the 1? Not really. It could be y equals x. All right, the last two problems, which you guys are experts on because we've been practicing labeling nonstop. Let's look at the first one. Sam raked 3 bags of leaves in 16 minutes. We're talking bags to leaves. Oh, not to leaves. Back that up. It says leaves in 16 minutes. Oops, I better do minutes. Woo. Miss Shaw. All right, 3 bags in 16 minutes. If he continues to work at this rate, how long will it take him to make 5 bags? Bags go up here with the bags. And this is my unknown. Do a little cross multiplying. 3x equals, go the other direction. That's 80. I want to get x by itself. Right now they're multiplying, so I'm going to do the opposite and divide. X equals, put that in your calculator. I'm going to have to round this because it just keeps going. So 26, maybe 0.7 minutes. Don't forget to label your answer. All right, let's do the last problem, and hallelujah, you are done. I would definitely go over this a few times. Make sure you feel good and ready for your test. All right, Mary ran 2 miles in minutes. Oh, we're down to miles per minutes again. All right, so I'm going to fill it in. Miles, 2 minutes. 2 miles, sorry. I'm done too. 23 minutes. Oh my goodness, we're almost done. How long will it take her to run at this rate for 10 miles? So I'm going to put the 10 up top. Oh, look. That was very similar to what we just did, right? 2x equals 230. Divide by 2, divide by 2. Show me your work. I got 115 and, whoa, what is that 5? Let's try that again. And then what were we solving for? Look at our equation. Oh, we were solving for minutes. Fantastic. You did it. You got this. Go over this again. Look through your notes. We had some excellent notes that had equations of proportions and graphs. It was all in there. Check those out and good luck on your test.